Okay, so today we're going to start talking about some of the very basics of Earth itself. So Earth is considered what we call an oblate spheroid. You'll see here in the picture, I actually have a picture of an egg. So Earth is pretty close to perfectly spherical, but it is a little bit more like an egg shape. So that's what I have a picture of here. Earth is said to have a global ocean. About 3/4 or 75% of the whole surface is covered in water. So a couple questions I have for you about Earth's interior. So consider these. Have we ever been to the center of Earth? Or have we even been through, let's say, just the crust? And if you answered no, the next question you should be thinking, well, then how do we know what's in the interior? And the short answer for now is we study earthquakes and the seismic waves they produce. And we'll learn more about that later on down the road. So let's look at the interior of Earth. When we look at the interior based on composition, and composition means what something is made of, we divide Earth into 3 interior layers. That's probably what you grew up learning, which consists of the crust, mantle, and core. So starting with the innermost layer, the one in the center, you'll see that it is composed of iron and nickel. It is approximately 3,500 kilometers thick. Above the core is the mantle, and it is made of molten rock, meaning melted rock or magma, and it is approximately 2,900 kilometers thick. That leaves the crust, the uppermost layer, and the part that we live on. And so it is composed of solid rock. The oceanic crust is much more dense and thin, only about 5 to 10 kilometers thick. Compare that to the continental crust, the part that we live on, is much thicker, ranging between 15 and 80 kilometers thick. So now let's look at Earth's interior. And when we look at the interior of Earth and divide the layers by structure, we actually have 5 layers: the lithosphere, asthenosphere, mesosphere, outer core, and inner core. So this time we're going to start at the top, the part we live on. The lithosphere includes all of the crust that we talked about and part of the upper mantle. And so this ranges between 15 and 300 kilometers thick. Below the lithosphere is the asthenosphere. It is less rigid, meaning it's not as structured. It's about 200 to 250 kilometers thick, and it's said to flow like plastic. And I actually like to use the analogy of taffy. If I handed you a piece of taffy and told you to identify it as a solid, liquid, or gas, you would likely identify that as a solid. However, if you attempted to bend or reshape the taffy, you could do that. And so that's what I mean by the asthenosphere can flow or move like plastic or taffy. Below the asthenosphere is the mesosphere. Meso literally means middle, and so there's not much to include upon that one other than it is solid. Below the mesosphere, we have the outer core, which is believed to be dense liquid, and is approximately 2,900 kilometers deep. And then the most interior part, and the last layer, is the inner core. It's believed to be completely solid and approximately 5,150 kilometers deep. So when we look at these layers side by side, you can see the 3 compositional layers compared to the 5 structural layers and how they line up approximately. So here's just a blank one with numbers 1 through 6, and you should probably go ahead and take a moment and try to see if you could identify those layers. So Earth also behaves like a bar magnet, meaning that it has one magnetic north pole and one magnetic south pole. And so Earth has this magnetic field around it. It's kind of this butterfly shape, and it's believed to be largely due to the large dense core that Earth has. We also have gravity, of course, here on Earth. And again, that's largely due to our relatively large, dense core. So, interesting fact. I think this is pretty cool. You would weigh slightly less at the equator than you would at the poles. Any thoughts as to why that might be? So let's discuss quickly weight versus mass. A lot of people use these terms interchangeably, but they are indeed very different. Weight does account for gravity, right? So I think most of us can accept that we would weigh differently on Earth than we would, say, the moon, right? Whereas the mass of an object is the amount of space it takes up. I don't take up a different amount of space on the moon compared to the amount of space I would take up on Earth, right? So I think you can see on that, using that explanation, that they are different things. The link here is a pretty cool site. If you go to that link, they'll actually allow you to calculate what your weight on Earth would be compared to other bodies, including the moon and places like Jupiter. It's a pretty neat link. Check it out. So again, using that link, you should have determined your weight on the moon, and you should have found that it is less. So would your mass, the amount of space you take up, change on the moon? And again, as we discussed, the answer is no, right? You don't take up any more or less space on the moon.